Our very first topic to discuss is computer hardware. Firstly, we will discuss the history of computer systems. 1940s. Computers existed, but they were room-sized machines. Only governments and research labs could afford them. That's it. No personal use, no business use. Then came the microprocessor. 1970s. That single invention changed everything. Suddenly, computing power fit on a chip. Now, regular people and businesses could own a computer. 1990s brought the internet, and with it, networking hardware became critical infrastructure. Servers, data centers, enterprise networks, this is the backbone that cybersecurity professionals protect today. Now, cloud computing. Physical hardware didn't disappear, it just moved. Those massive data centers still exist, they're just someone else's problem to manage, but they're absolutely your problem to secure. Today, AI-optimized chips, edge computing, and on the horizon, quantum computing. Quantum doesn't just upgrade existing hardware, it introduces an entirely different architecture, one that can break encryption methods we currently rely on. Moving ahead, we have types of hardware, and it's of two types, internal and external. Internal components, the parts living inside your machine. CPU, the brain, executes every instruction your system runs. Modern ones pack billions of transistors on a single chip. RAM, temporary memory. Whatever the CPU is actively working on lives here. More RAM, smoother performance. Storage, HDD or SSD. HDD uses spinning disks, slower, cheaper. SSD uses flash memory, faster, more durable. For any serious workload, SSD wins. GPU handles graphics and visual computation, comes integrated in the CPU or as a dedicated card. For cybersecurity work involving data processing or AI tools, GPU matters more than most people think. Motherboard connects everything. PSU powers everything. Cooling keeps everything from dying. That's internal, simple. External components. Peripherals, things you plug in. I/O ports, USB, HDMI, Ethernet. These are your entry and exit points for data. In security, these matter. Every port is a potential attack surface. Networking equipment, routers, modems, switches. This is what connects you to everything else. Also what attackers target first. Everything else? Monitors, keyboards, webcams, external storage, you already know what those do. The point isn't memorizing the list, it's understanding that every single component, internal or external, is something an attacker can target, misconfigure, or exploit. Next we will understand the difference between hardware and software. Hardware is physical, software is instructions. Hardware does nothing without software telling it what to do. Software is useless without hardware to run on. That's the relationship. Simple. CPU renders your text editor. GPU renders your game. The software just tells them how. Now comes the topic of hardware virtualization. Virtualization. One physical machine, multiple virtual environments running on it simultaneously. How? A hypervisor sits between the hardware and the virtual machines. It allocates CPU, RAM, storage to each VM independently. Why does this matter? Instead of buying 10 servers, you run 10 virtual machines on one. Lower cost, better scalability, cleaner infrastructure. This is the backbone of every major cloud platform: AWS, Azure, Google Cloud. All of them depend on hardware virtualization to deliver on-demand computing at scale. And for cybersecurity, virtual machines are everywhere. Malware analysis, isolated testing environments, sandboxing. You will use VMs constantly. Let's understand hardware in business. Business hardware is the same concept, just built tougher. Servers, storage systems, networking equipment. Enterprise grade means more reliability, redundancy, and control compared to what you use at home. Most businesses today run a hybrid model. Some infrastructure on premises, some on the cloud. Best of both worlds. There's also HaaS, hardware as a service. Instead of buying hardware outright, businesses lease it from a provider. No massive upfront cost, always up to date, maintenance handled for you. It's basically a subscription for your physical infrastructure. And AI is changing business hardware too. GPU servers and AI accelerators are now standard in enterprise environments, powering machine learning, advanced analytics, automation. As a cybersecurity professional, understanding this infrastructure is non-negotiable, because this is exactly what you'll be protecting. This is all you need to understand for computer hardware from hackers' point of view. So, that's it. See you again with next topic of cybersecurity. Hope we will finish this journey together.